the Washington machine?
No!
Washing machine? Let's go Washington, D.C.
No, it's Washington. Did you throw it in the wash? I know, it drives me absolutely crazy. This is the washer method.
You're saying the same thing.
Now it's used for solids with holes. Used for solids with holes. This should kind of make sense. It's the integral of the outside ring minus the integral of the inside ring. Let's think about what that's doing. Remember, the integral of the area is the volume, correct?
Sure.
So when I take this integral, I'm finding the volume of the whole object as if there isn't a hole. And then I found the volume of the inside. I take the whole minus the volume of the hole. It's going to give me the leftover. Yeah.
So will you have to break the integral up, or will you?
Sometimes. So yeah, that is an option. Sometimes you can go ahead and straight up integrate. But yeah, a lot of times you do it to break it up. It all depends on what functions these are, and if they're easy, if they need substitution, because that's another good point. If one needs substitution and the other doesn't, you've got to break it up, remember? The key thing is, this has to be the outside. Outside minus inside. Which makes sense. You want the whole volume, subtract out the inside volume of the whole. You want the leftover.
So you get negative answer, negative. So
Exactly. If you're negative, you're in trouble. No, shouldn't have a negative. No, you don't slap some absolute values on it. Questions?
just ignore me.
Why is it called the washer method?
Guys,
Like
name
a
is washer.
washer?
No, the guy's not name is a washer.
Washer.
It's a washer, like exactly like you would use, yeah. Like those who don't know what a washer is, it's a little tiny disc with a hole in the middle.
Put your clothes in, clean.
Yeah, not that washer.
Oh, not in the washer.
There's also a dishwasher too.
Sounds just Washington. You get a wash rack? Wash rack.
Find the volume of the solid. Find the volume of the solid formed by revolving the region. Formed by revolving the region. Bounded by the graphs of y equals square root of x. Y equals x squared and the x-axis. Okay, are we ready? Let's draw a picture, of course. Now these pictures need to be really good. Okay, we have the square root of x, which we all know looks like that. And I have x squared, which we all know looks like that, correct? But going through the axis for some of this group. Yeah? And I want the region bounded by the 2, which is this, correct? And I'm revolving that around the x this way. So when I do that, you're going to have that reflection, right? But the outside is going to look like it's there, right? So when I revolve this around, it's going to look like it has an outside shell.
Yeah.
But really along the inside, you see how it's going to be hollow? So there's our case with the hole. It is, very weird hole. Okay, so outside. So pi r squared. Now in our case, the radius to the outside is that function, which is square root of x. Should I just have pi x on the outside? Now Now the inside, when I draw the inside radius is just going to that first function, which is x squared. So I have pi x to the fourth. So my integral, outside minus inside, let's go ahead and factor out that pi. Right, I can go ahead and pull it out. The outside function is x minus x to the fourth. So I have outside minus inside. Now I need to figure out bounds. Now we know one of them is 0, correct? The other one is, when does square root of x equal x squared? 1. Does everyone agree with that? Now 1. So let's take an antiderivative. 1/2 x squared, 1/5 x to the 5th, 0 to 1. Plug in 1, I get 1/2 minus 1/5. Plug in 0, I get 0. Common denominator times 2 times 5. And 5 times 2, bless you. So I have 3 pi over 10. Which is kind of amazing when you think about it. We took scooped out, that's not included in our volume. Just the actual kind of shell that we're looking at. 3 pi over 10 is not much. Was that barely, maybe 1? Maybe.
Are you gonna have to find the volume of like the container?
What's that?
You're gonna have to like find the volume of the container on the inside.
I've never seen a question, but I can't say never. But it's usually in this context. They don't really put it in Calc 1, you don't put it in context. But, yeah? Let's try another. Find the volume of the solid. Find the volume of the solid. Formed by revolving the region bounded by the graphs of y equals x squared plus 1, y equals 0, x equals 0, x equals 1, about the y-axis. This one is interesting. Interesting because I have lots of options on this one. I can try different things, but I'll let you guys decide what you want to do. Let's draw a picture. 4x squared plus 1, parabola up at 1, correct? And then y equals 0, that's the x-axis. X equals 0, and x equals 1. So I've got this region going on right here. And I'm revolving around the y-axis, so it's going to look something like this. You see it? So, only the top, it's like you scooped it out, but the bottom is solid. Okay.
You should just take a square and that's
Well, because isn't that going to be your, what's going to be your, like inside and outside?
Well, that's what we're going to get to, but do you understand the picture?
Yeah, yeah.
Okay, that's all I care about right now. We're going to get to the actual seven here in a second. Because this is what I'm talking about, lots of options. I could do lots of different things. Okay, lots of different things on this one. Okay, now, here's one option. I can cut it off where I start to have a hole and where I don't. I can find that volume, and in fact, I can find that volume really easily. Because what is that shape?
Cylinder.
That's a cylinder. I could find the cylinder, and then I could set up an integral just for this, with outside, inside, then add them, correct? There's one option.
The whole cylinder minus the top.
I could do the whole cylinder, the whole thing. Then I could set up minus just the scoop, but then I have to have my interval be different. Okay, and I kind of avoid that. I don't like our intervals being different because I think people forget to change them. Okay, let's go ahead and just find this bottom and then we'll find the top. Okay, so let's look at the bottom part. What's the volume of a cylinder? Pi r squared h. In our case, what's my radius? 1. What's my height? 1. So the bottom has a volume of just pi. With me there? Now let's do the top part. Does everyone see how you have that scooped out, that there is a hole that is not solid? It's going to look solid from the outside. When you look in it, it's more like an actual bowl. Okay. Alright, so for the top, we need to identify outside, inside. The outside, pi. Now when I do this to the outside, the radius is 1, no matter what, correct? The outside. So the outside is just pi. Inside, whoop, why did I disconnect? What the heck? Randomly decide, no, now you gotta connect it? No. It just shut off. What the heck? Oh, user error. Technology. Randomly shut off on me. Okay. The inside, if I were to draw it, the inside, really?
You're drawing the graph.
I know, I can't see where I'm at. That's what I'm saying. I can't. There we go. Okay. The inside just goes to that function. What is that function?
Square plus 1.
It is not.
It's square root of 1.
Yeah. Isn't this in
Square
terms
root
of x? We are evolving this away. You better be in terms of y. Right? So it is actually, yeah, the square root of y minus 1. Which will just give me y minus 1. You see that? Big common mistake that you've got to remember. If I'm revolving around a vertical line, it's got to be in terms of y. Okay, that's a big mistake on this problem. So now, when I integrate this, I'm going to factor out the pi. My outside was just pi, so what am I going to put in here? 1. I factored out the pi, correct? There's still a 1 left. Minus that inside dy. You with me there?
Yeah.
Now, what are my bounds?
0 to...
Now, be careful. I'm working on the top. So I'm going 1, and I have to figure out what that is. Now, the easiest way to do that is, you know that this is true, correct? And you know this is the line, x equals 1? Well, plug it in.
2.
Yeah, y goes to be 2. Does that make sense? Okay, so I really have pi, the integral, that will actually give me 2 minus y. When I distribute, correct? The plus 1. So my antiderivative be 2y minus 1/2 y squared from 1 to 2. Plug in 2, I get 4 minus 2. Plug in 1, I get minus 1/2. So really think about it. That gives me 2 minus 2. So really I end up with just 1/2. Follow that? But that's the top. So top plus the bottom which is
3 pi.
3 pi over 2. So the volume of that whole shape with the inside of the top scooped out, 3 pi over 2. Not the only thing we could try there. I personally think it's easier to kind of use your cylinders and split them up. Yeah? Okay. Let's try another.
Time works here. Yeah,
Oh, well, she was. Because I feel like she was. Thinks we should go with 6. Watching Breaking Bad over the weekend.
Pretty good. Good
Big
income.
question here. Do you know what this looks like without a calculator?
But we should.
Yeah. Of course we know what EZX looks like. Yes?
Yeah, that one, yeah.
Now, the other one is just off by a negative, right? Now, we know that multiplying on the outside does what? Multiplying by negative on the outside does what to the graph? It reflects it
ADX.
about
X.
the x-axis. What will it do if I do it on the inside of the function?
That's not the Y.
What about the y? Exactly what it does. Okay, so this graph, I know e to the x looks like this. E to the negative x looks like that. And x equals 1 is this vertical line. Yeah? This region is entrapped by all three. You visualize that? Now when I reflect this, be very careful. See, I have a gap there? When I revolve it, there's still going to be a gap there. Yeah? So it's going to look like that. And then it's going to be kind of filled in. And this is crazy because there's no bottom to this shape, is there?
It's just a ring.
Yeah, it's just a ring. With kind of an interesting curvature in the middle. But be very careful. A lot of people draw this incorrectly. They instantly start drawing at the axis. Be careful. If you have a gap there, you better have a gap on the other side when you revolve it. Because it's got to keep that same radius all the way around.
Just trying to imagine.
Football puck.
Yeah. Like a what?
The little football, the names, that's what they call them. They used to hit the ball and kick field goals. Chuck.
The town? No.
I know it looks like.
Yeah, I think so.
I don't know.
I'll pick it up and show it down to you.
Good. I'm glad someone is. Okay.
I'll send one here.
So here we go. Outside. My outside function, well here's the center of the object, correct? The outside function is what? E to the x. Which is e to the 2x, correct?
Yeah.
Everyone with me there? Just multiply those power to power. The inside when I go from the center of that object to the inside, what is that? E to the negative x, which is pi e to the negative 2x. So my integral, I'm going to pull out the pi, it's going to be that outside e to the 2x minus that inside dx Now bounds, going from 0 to 1, which I was given in the problem, correct? That is in the line x equals 1. Now here's exactly what Casey was talking about. Do you have to split that up? Here's a case, well yes, I do. That requires substitution, so does that. You need to split those up. So I have the integral of 0 to 1, e to the 2x dx, minus the integral of 0 to 1, e to the negative 2x dx. So remember, if one requires substitution, the other does not, or they require different substitutions like this one, you've got to split them up. So in this case, can we kind of go ahead? We should kind of know that one in our head, though, to be honest with you. I'll help you out. 2x du. Well, actually, no, because let's change our bounds, because some of us are still not changing our bounds. So I have 2 dx. Dx is 1/2 du. 0 becomes 0. 1 becomes 2. So I have the integral of 0 to 2 e to the u times 1/2 du. With me there? Minus, I'm going to go ahead and do this other one. U is negative 2x, it's going to be almost the same thing. Du is negative 2x dx. Negative 1/2 du. 0 becomes 0. And 1 becomes 2. So I have the integral, think about it before I do some work. 0 to negative 2, can I go ahead and flip it and make that positive?
Wait, isn't it?
There's minus to begin with.
Yeah, okay.
It's going to be in the wrong order, so I just flip it and make it positive. So that's e to the u times negative 1/2 du. Are you with me so far? Okay, so this antiderivative is just 1/2 e to the u, evaluated from 0 to 2. Plus this antiderivative is negative 1/2 e to the u, evaluated from negative 2 to 0. It's getting messy, but we can do it. Plug in 2, I have 1/2 e squared. Plug in 0, I get minus 1/2. Here, plug in 0, I get negative 1/2. Minus, plug in negative 2, I have plus 1/2 e to the negative 2. Not much I can do that other than clean it up. Pi, let's see, that will give me negative 1. I'm going to have e squared over 2 plus 1 over 2 e squared minus 1. And personally, I would probably just leave it like that. Because you can't really combine. Now, you can get a decimal so that you can check, of course. But that's about as pretty as that one's going to get. Questions? It's really not anything terribly new, only we're kind of doing like 2 problems in one is what's going on. Alright, then I'm ready for you try. Volume of the solid results when region bounded by y equals x squared, x equals 0 to 1, and revolves about the x-axis. Give you an easy one, I think. Just to see if you get it. don't even know what they're asking. Well, he picked a couple questions, and he picked lower level, he didn't pick high school, he picked like second grade, something like that, and did a demonstration of like some of the answers, and it is hilarious. I mean, he's talking about the Common Core, and it's funny, because this one kid's response is second graders, because it's like, explain using this picture, because the question was just ridiculous. It was like 25 minus 17 is what they needed to do. Like, you have 25 apples, 17 oranges, how many more apples than oranges do you have? Draw a picture with a number line, just, I mean, it was just like the directions were insane when all you had to do was subtract. It was like explaining, this kid was like, I forget his exact words, but he's like, I did 25 minus 17 because the voices in my brain told me to do that, and my brain talk said it was right. That was so funny, it's like my brain talk. Awesome.
Sprinklers are on, guys.
Gonna be pouring all day. Better than what's gonna do tonight, so.
Heard it's gonna snow.
Yeah.
Snow day tomorrow.
There's not gonna, you're not gonna, it's 70 degrees all weekend. It's just gonna be a
ground's like
nuisance,
60
that's
degrees.
all.
What? I'm going for a snow day.
It's just gonna be a nuisance.
Hey,
Hey, I'm not coming to school tomorrow.
Senior skip day.
Yeah, right. What do we think? Yeah? Pretty good? Day 3. The whole point is you need a good picture. Because some of these get weird, spend the time on the picture.